No. Okay. Good?
Yeah, you're good.
Okay, cool. Hi, everyone. Glad you're here. Today, I'm really excited, even though it's kind of weird to be excited about compliance in some ways. Today, I'm going to be talking about compliance as code. We're going to be focusing a little bit on InSpec, though we're going to touch on some other ways you could potentially do compliance as code in your organization. My name is Ken Gruber. You can follow me on Twitter, posting stuff, InfoSec, Twitter, you know. I don't do a lot of compliance posting. It's a lot of like Golang programming and stuff like that. I work on a lot of open source projects, and I tend to write about them. You can find me on Medium, that same basic thing. Some of the stuff I've written about, just to kind of give you an idea of the stuff that I like packet analysis in color. So it's like you have like Wi-Fi stuff, traffic going on. You have a PCAP, right? You can easily represent that information as like a 256-bit color like scheme inside of your terminal. And then you could get something like this very beautifully with a little bit of command line magic. And, well, sort of random, not as helpful as something like Wireshark. Interestingly enough, you can do some interesting analysis like those little like teal lines are like me pinging out to Google. So you can get interesting patterns just by doing basic color analysis, which I find very fun. I used to be an art major, so, you know, that kind of stuff. And even like the more heavy programming stuff, like building a high performance asynchronous port scanner with Ruby. Yeah, like getting like very fast port scanning speeds. It's single threaded with Ruby using modern asynchronous IO libraries. So traditionally people do like multi-threaded either Ruby or Python programming, and they'll realize that there's some bottlenecks that you'll come across in a single threaded programming language. While you can spawn as many threads as you want, you're really going to get the best benefit in actual IO bound tasks. So this is reading from disk or writing to disk or reading from the network or writing to the network, whatever you're doing, right? Single threaded is the way to go with those languages. And then with a language that is good with multi-threaded, I love Go, so I wrote building a high-performance port scanner with Golang and going into that. You can find all my code on GitHub. Basically, I open source almost all of my stuff. Some of this stuff from this talk will also be on GitHub once the talk is done. I just have to turn it from private to public. So again, I love open source. And you're going to see some Miyazaki gifs. I like anime stuff too, so you'll see that. And these are the programming languages I spend my most time in. I spend working with the most effectively. There's other languages that are there, though these are the ones that I tend to do most of my work with. Some of the projects that I've contributed to may or may not use, I like Subfinder. It's a subdomain enumeration tool. There's even like all the code again, open source on github.com/subfinder. And there's even a web application that you can go hit and do subdomain enumeration, subfinder-vspot.appspot.com. You get 500 results for free. You can do as many as you want, really. Now, I also have contributed to BetterCap. That's another tool maybe you've used before. I love working on code. Like I maintain the Shodan Ruby gem, and I got the hybrid analysis. So it's a sandbox. I wrote the Ruby gem for that because there was a Python one that existed, and I might as well like for the community like add a Ruby one if people like Ruby, and I tend to like Ruby for some cases. I've also contributed to random bits of Metasploit, like some really random pull requests. I've optimized random parts of that code base, and you know why not some memes in here. So, InSpec, with some slides, and now you know who I am. Let's get into a little bit of what this is, because this is rather interesting, I think. So, it's built by the people at Chef. What is it? It's a open source testing framework for infrastructure with a human and machine readable language for specifying compliance, security, and policy requirements. Effectively, that is a lot of words. Effectively, it just turns... it's built by the people at Chef. You do not need to use Chef in order to use this product. I do not use Chef at all, but I respect a company that's making tools and open sourcing this work. What's really interesting about InSpec is that it was actually, originally, the idea came from server spec. Server spec, you can write RSpec tests to check your servers are configured correctly. The guy that runs this is a totally open source project as well. He sort of thought, well, he was a Ruby developer, and RSpec is a behavior-driven development framework for Ruby. So this is like the standard testing framework for Ruby that people end up writing tests for. So he kind of thought, well, I'm writing all these tests for my application. Why not the server configurations as well? Actually having like a codified version of like what you may have in like a simple bash script to do like grepping inside of an SSH configuration file or something like that. So that means InSpec is written in Ruby. I'm a Ruby fan, and you do not need to be a Ruby aficionado in any ways to learn InSpec. Its main goal, in fact, is to be very easy for non-coders to use. And I hope you'll see what I mean by that. So InSpec is a Ruby-based DSL, a domain-specific language in order to describe these policy and compliance requirements that you and your organization may have to follow based on whatever standards, or the ones that you're setting up for your developers or whoever's engineering these applications in order to have automated guardrails. So a domain-specific language specifically because you could use Ruby, you could like kind of code out all these specific pieces yourself, but the domain-specific language allows you to sort of not have to, again, know Ruby. You just need to effectively know the language that you want to work with, which is compliance in this case, whether or not like a kernel module should or not be installed in some cases. So I find this super helpful, especially because some of this work has already been done. Some of the heavy lifting in order to read many configuration files has been done for me, and I just have to learn this nice little syntactic sugar on top of Ruby in order to describe these things. And it becomes very easy to automate. And whenever you need a general purpose programming language to fall back on for whatever it is, like literally defining an array with a bunch of whatever in it and then iterating over that array. I'll show an example of that. This becomes very, very powerful, especially when you're maybe limited to things that are like YAML based. And then you have to do whatever weird syntax in there to figure out if there's like an if-then, which is like based on the actual framework that's reading that YAML, because YAML is just a serialization language. So having a general purpose programming language becomes very powerful because you always have that to lean back on. You could like literally like grab parts of Metasploit and throw it in your InSpec code. Like it's like just full Ruby if you wanted to treat it that way. So let's kind of dive into that. So with InSpec, relatively simple process to get started with. So you write a test, run the test, and then you interpret the results. You can get a little, you can go a little further with that. But let's kind of start with it. So we're writing a test. So this could be an example, very, very simple example test, right? But it's a control that's called example 1.0, because maybe there can be some more examples, who knows. And then we have a title to ensure root logon is disabled via SSH. This is just saying what this control is doing, what we're kind of about to describe. So what are we describing? That the SSHD config, permit root logon should compare to yes. Or it should not compare to yes. Oh God, I said that totally wrong, right? But what's nice about this is that it's relatively human readable. It's not even doing like double equal signs or anything like that. You're not asking an auditor to read that kind of code to show that you're in compliance when you're running these profiles. You show that it should not be enabled or should not be installed, etc. So then you would run the test. So that's a simple test. Let's run the test. On the command line is one way you could do this. So we could do inspec exec and then the path to the file. So this example SSH profile. You could optionally add an .rb to maybe help with Vim syntax coloring or something. But we have the test, we ran the test, what are the results that we got? Because this becomes very important, right? Well, this is an example on the command line. This is just like copy-pasted from the example InSpec stuff, so it just shows you that these things passed, and there would be a red for failure, and I'll show you that. So let's just kind of just go over, like, you can describe Nginx configuration file, or packages, such as Nginx, whether it should be installed, what version you want specifically. You can describe whatever, and then, for example, this like array that I'm defining. Since it's just Ruby, I can define this array of packages that I don't want installed on my system. It's never going to production if you have these packages installed, even if you, right? Then for each one in the blacklist, each item, I'll just describe this package should not be installed. And this becomes, again, very, very human readable. So another example, there's plenty of examples online. And of course, it's not just, that was very Linuxy, right? It's not just limited to a Linux system. It is very much built for Windows stuff as well. So you can describe many things, such as a PowerShell script, hotfix patches, etc. IP tables rules, and it runs on all the things, which is fantastic. Here's like an example of some of the stuff that it runs on, whether it's Docker, macOS, Ubuntu, Windows. I don't care what you're running on InSpec. It is an ageless thing that as long as you have SSH or WinRM, some way for me to be able to get into the box to see the state of the system, that's what all it requires. So if you're running something like Ansible or any other thing like that, this is sort of that same kind of mindset. And just for fun, I don't know why I had Ubuntu twice in there. So yeah, you can run your test locally. So I could run a test right on my Mac right here, and it would just, it wouldn't SSH into it, but it would just, run it. We could also SSH into a thing, which is great. We could do the WinRM, and we could also test Docker. And this is kind of the syntax here. So everything has like an API, right? And that's becomes very, very nice to interact with. And so, for example, if you're describing your cloud infrastructure, maybe you never want something to go into production unless your user has multi-factor authentication enabled or something like that. Or you just want to check, do you have multi-factor authentication enabled? You could just write a simple InSpec test for your username and run this test to check that. This goes really, really well for continuous integration, continuous delivery, whatever CI/CD thing you're doing. Because if that check is there, you codified this process, it's no longer a manual auditor or someone having to go into the system and manually look at that. That doesn't scale well, right? You have to be able to take these processes that you're doing on either a day-to-day basis or the things that you're going to be protecting people with, and you need to hopefully make it actionable. So, and you can describe like all sorts of hilarious stuff. Like you can describe even the virtualization system that the thing is running on, such that it should be Docker. Or what should it be? VirtualBox. Anyway, those are just for fun. And you have all these different tools. Like there needs to be a way to help codify the processes to check these things, whether it's you're using AWS, Google Cloud, Azure. These things have APIs, so why not automate that instead of going in the GUI and checking those things? Doesn't necessarily make sense. So I don't care what you're using, since InSpec is extensible, whether it has something built into it or that doesn't matter. Usually the community has been building something. For example, Google Cloud is not supported really officially by InSpec, at least in the like official documentation. Someone from the community came around and made their actual InSpec, plugin so that you could test your Google Cloud configurations, because that's what they were using, right? And so the community has been very much so stepping up to the challenge of writing stuff so that you don't need to go write that Ruby code. You just need to know basically the syntax to write, right? So it's really good for the operations standpoint, overseeing those things. So that kind of plays in the compliances code and your infrastructure's code, right? Because in many cases, like I end up using Terraform, Vagrant, and these tools in order to codify my virtual machine spinning up, right? I have my code that I've written to spin up the infrastructure. Whenever I write code for my applications, whether it's a web app or whatever, I write tests. So if I'm writing my infrastructure as code, writing the actual tests for the infrastructure as code too becomes kind of natural. It follows along that same sort of very much developer practices that are kind of bleeding into things outside of just building out a nice iPhone app or something like that. And so here's a kind of nice example. So I say I use these things. What's a big example? Here's like an example playbook that I would potentially use to like do something on a system. And this would be a Vagrant file that I would actually spin up. So I could spin up a little Ubuntu box that's 1804. It's built by the people at Chef in their bento project. That's kind of a but just a nice little syntax sugar that if I ever want like a CentOS box, it's like CentOS/7 or whatever. And then I would have a private network. So this is just spinning up a local virtual machine with VirtualBox. This would be like the private IP that it'll be provisioned with. And this would be like the host name that I want. And then I want VirtualBox with 2 CPUs and 124 megabytes of memory or whatever the case is, whatever the thing. And then we're going to provision with Ansible, and it's going to be that playbook, and I'm going to limit to the host lab. You don't need to know Ansible or anything like that, but I'm codifying all the processes that I would run command line tools to be like, or go into the GUI or pull down ISOs or any of these things. All of that's already been codified right in this little file. That's, I don't know how many lines long. I don't have the numbers, but very short. And so this example just kind of lives in a directory tree, right? And on the command line, what I would do for this infrastructure's code bit, if you're not too familiar, that's why I'm doing this example. You would type like Vagrant up, like some stuff would happen, you get diagnostic information, we're spinning up, blah, blah, blah. And then, cool. Then you do Vagrant SSH. We're in the system. And it has, the Totoro host name and stuff like that. I'm done with the system. I exit. And now I could actually just destroy it. And now like all the VirtualBox things are gone and all that magic has been cleaned up. So this becomes very, very nice to spin up a lot of different boxes. Like I spin up my Windows boxes, my Linux boxes, whether it's CentOS, Ubuntu, whatever. I usually end up spinning up in this fashion. Becomes really nice to automate. And if you spin up and manage a lot of VMs like I do, not having this tool just makes it a real pain. And when I found this tool, it was quite literally a godsend in so many ways. So that's super Gucci. But this whole like InSpec thing, right? So writing tests, so that's like an example of my infrastructure that I've written as code. Very, very simple example. It's not doing anything too important, but I want to write tests for it. So in this little directory tree, I just want code, right? How about I just add my InSpec test here? very same logical sort of operation. So my example test, this will be my test. I'll describe the OS host name should be Ubuntu, and that should fail. It should be Totoro, right? I changed it, sorry. Anyway, describe sysinfo, host name should be Totoro, OS name should be Ubuntu. I didn't read ahead. And then describe the virtualization system should be VirtualBox, and role should be guest, whatever. All the random configuration that I just set up for this example, I can describe basically how that should be set up in this InSpec test. I run the test. Now, there's some extra stuff where I'm SSHing the vagrant and then providing the private key, but you have those command line flags. You can go do a help menu to find out more. And this would be the output of that test, of that command that I just ran there. It would be, the actual operating system is Ubuntu. We have the host name. We have all those things. They all passed, right? And so that logically just kind of follows that really nicely, that infrastructure as code mindset. We have a file there. And if I wanted to, I could literally take that out, and it didn't really affect the nature of the system, right? The only thing, in this case, that would affect the nature of the system is that my playbook would fail if I took that out too, or if I couldn't spin up the system, or my vagrant. But this is a totally separate thing that just can go inspect the state of it without really affecting it for the most part, which is, I think, very nice, because it allows you to build up your faith in InSpec and your knowledge of it as you go along. You want to describe more and more things. So this is just code, however you chop it at the end of the day. And this really goes well into version control if you're already doing that. It's really nice, I find. So obviously that code can go into Git. It can go into GitHub as well. You can share your infrastructure. You could share how you're building stuff out. Obviously, you can do a private repository in GitLab, whatever the case is. But over time, as let's say we wanted to change the host name to not be Totoro or something like that, that could exist. And that's now that's actually a process that's really nice to track over time to see when that commit happened that we changed all of our host names to this thing. And since it's in this nice readable format, it doesn't become very hard to navigate those Git diffs, figure out what's going on. Because if you were doing bash scripts or something like that, stuff can honestly get a little dirty. So this code will exist here, vagrant Ansible InSpec under GrrCon 2018 on my GitHub. I just have to, again, make that public. So going a little bit more into InSpec, it's an extensible language, as I said. So if any of the things I show aren't what you need specifically, you can always build on top of it, and they have plenty of examples for you to build out your own InSpec resources or matchers, or they have different words for what you're describing. And it's great for codifying agreements. So if the developer is always going to have multi-factor authentication enabled, or this is going to be a thing, this is a SSH profile that we're going to use on all of our systems, we can say that that's going to be the case, and then it's not just living in a PDF or something like that, or in a wiki. It's actually something that, again, could exist in the pipeline before you even get into production. And automating those compliance check-ins is also very interesting. So literally, I'll get into it. And then these become reproducible, because no longer is it the manual process of going into a box, SSHing, and maybe fat finger command or doing something stupid. You've actually put it into a systematic framework, and you can always continuously run it to check that you're always continuously in compliance. It doesn't have to be all the time, right? It could be every day, it could be every 2 days, whatever you would like to set it up as. It could be a simple cron job, scheduled task, etc. And I really like it because it's not just a wiki. I find wiki and sharing information very important, and not everything can exist so easily in a code base. It's simply not the case. Things are so much more complex than that. But not being a wiki is very nice in the case that if you had an actionable task that you could run on a system, it's very nice and easy to check things. And it becomes very collaborative in the code sense, because while you could also collaborate on a wiki in PDFs, and that's fine, I find the collaboration in code to be a little bit more rewarding in some cases, honestly. I get to see the output of that code and stuff like that. And I find that very nice. And obviously sharing on GitHub, the social coding aspect of it becomes very important. And it's obviously not just documentation. While it can contain documentation metadata, especially references to the actual PDF that you're trying to comply to, or whatever the case is. And one of the examples of turning a PDF into an InSpec profile, I'm just going to follow, is a CIS benchmark. Then we're going to go over one. If you don't know what the CIS benchmarks are, it's basically a bunch of rules, and then they have a name, the profile applicability, description, all these different fields. And you scroll down this 100 pages, whatever, PDF, and you go through it, and you can see if you're in compliance. And some of them are scored and not scored, whatever. So let's translate a CIS PDF documentation into an InSpec profile. Just a small example, a small part of it. So the example I'm pulling off from is the CentOS Linux 7 benchmark. It was like grabbed it online, right? And then let's just follow the very first thing outside of like the overview, recommendation, initial study. And then we got to the actual like control, which is like ensure the mounting of the CRAMS file system is disabled. Oh, all right, well, let's do it. So if we were to like look at that PDF, this is basically what we would see. I've like kind of cleaned it up just a little bit so it fit on a slide. But we could look at it like it has the title, the applicability, it should be on servers and workstations, okay. And then a description of it, some rationale, okay. The audit, this would be like the command we have to go and type. Okay, like mod probe and crab, all right. And it should have that as the output. And if we do this, it should have no output, okay. And then edit this file, and that's what you do if the case it's broken. Okay, I can kind of follow along with here. Not too bad, but I want to automate this task. So I want an example box, so I'm going to use Vagrant to spin up a little CentOS 7 box. Vagrant up, it's there, cool. And now I'm going to write this InSpec test, right? I'm going to have a control, it's called CentOS Linux 7 Benchmark 1.1. You could name it whatever you like, however your system, however you want to name it. There's no forcing of these names or anything like that. Like you don't have to have these 1.1s or anything. So the title, so I've just literally copy paste. You could also like parse the PDF and try to do it that way to automate this task as well. So title, description, and I just like literally copy paste it off the PDF so that control, that actual compliances code bit contains that information that the benchmark you're trying to like actually adhere to. So you can optionally include these. You do not need to include those things, but they're really nice. Then we can have a tag, for example, like I can arbitrarily add the CIS tag, so I know like what CIS thing I'm trying to adhere to, maybe a level, because that's what they have in there, like what level, you know. And then this is the actual test bit, right? So like you have all that metadata, but then the actual test, the kernel module CRAMFS, it should not be loaded, and it should be disabled. And that's very, very human readable, outside of just like the nice little examples right here, right? It's literally, it should not be loaded, should not be disabled. And if we were to run this, like right when I spun up the Vagrant box, we would see that, you know, it should not be loaded, so it wasn't loaded, but it wasn't disabled. Okay, so I failed this test here, and I didn't pass the entire control, which is why this failed, right? So I have one success, one failure, and one control failure. I can read that output, and this is also really nice if you ever want to pump this into something like Elasticsearch or something like that continuously. You can output this as JSON, and that becomes really great. Whatever can consume JSON can consume that. So once we have like our fail, let's do something about it. Like maybe we'd write like an Ansible playbook to actually go ahead and we fail that part of the audit. Maybe we'll have something to actually go in, not just look at the state of the system, but then actually do something about it, right? Then we could, you know, pass it. So I'd run the Ansible playbook and we'd be able to pass, right? But I want to make sure that whoever's running this audit, if they were to see that failure, they could know that the remediation, or like say the continuous integration thing, like whatever your system is, could look at the remediation tag then, and then whatever the path to the playbook is, it could then go run it. Or, you know, the human could say, oh, I'm just going to go try running that playbook. Whatever your system is set up. Like, I understand that everything is automated in many cases. So this becomes really nice because I can just arbitrarily add these tags, arbitrarily add reference information, stuff that maybe exists in the wiki, maybe point to the wiki here. These becomes just a nice metadata aspect of the actual framework, which I find very, very helpful. And that's really cool. Like, I find that very, very nice. Like, that turned that PDF into like an actual task that I can run on a system, whether it's on my actual Vagrant box or whether it's in a remote system on AWS. This control is like very simple. And what's really nice is that you could do obviously Windows security with that as well. Like a really great blog post by Adam Leff. He basically was like, well, the WannaCry thing was breaking out, and he was trying to, you know, he's an InSpec evangelist kind of guy. He works for Chef. So he was like, well, you could test if your systems are vulnerable to WannaCry with InSpec, which is very true. And you could easily check these hotfix, these actual like Windows patches you should have on your system to not be vulnerable. And if you didn't have, and I didn't have them all, there's a whole bunch of them, but you list them out and then you could check, well, this Windows hotfix, it should be installed. Cool. You could also say it should not be installed too, right? It just depends on how you want to build out the test, right? In this case, should not be installed, and that's great. You could do port scans or just little spot checks there to be like, these are the good ports we want on our system. These are some bad ports we don't ever want on the system. And we could describe each good port, it should be listening. And each bad port, it should not be listening. Which is, again, very nice. This is much cleaner than a lot of like bash scripts that would do the same exact tasks. So, other options that exist. There are plenty of other options, though some cases they're not as polished. One example. So maybe you hear the Ruby thing and you're like, I like Python, Kent. And that's okay. No worries. The test infra project is very interesting. It's actually directly inspired from server spec. Like if you go on GitHub, it says a server spec alternative written in Python. Now like another alternative is InSpec, but test infra is just Python code that you would use literally the PyTest framework, and you could test the password file, whatever Nginx, and this is just the example right off of GitHub. The thing I don't like about this though is, well, it's not bad. It's definitely not terrible. It's not as nice if you are not a code person. An auditor could very easily read something should not be enabled or something should not be installed, though this becomes kind of interesting here, where this logic hasn't been like stripped away and it's very raw, very code-like, right? And you may like that. You may not like that. We have the nice case here. We do get to nice syntactic sugar. Something should be installed, right? And so it's not impossible. Just it's not as polished. And sadly, it's not as up to date as something like InSpec that has the company of something like Chef. But if you want to go on, make it better, 100%. If you like Go, there's Goss. And if you like Miss YAML, Goss is pretty much full YAML, those written in Go. So like this would be like the test you would write in Goss of like something should be listening. And this is like the default SSH profile that you could get right out of Goss. So whatever. OS query is another great example. If you wanted to like have like the state of your system, be able to inspect that. It's built by Facebook. And this would be like, this is literally a thing to check if, give me all the disks that don't have encryption enabled. So this is not as human readable. I hope you like SQL, if you're doing that. But it's not bad. It's also another way to look at the state of your system. And I don't really care if you don't use InSpec. I'm not paid by Chef or anything like that. I simply like the idea of something being human readable. And that becomes very, very important, I think, compared to when you have other examples like SQL, which doesn't really become super readable, or like what's the intent, right? Like, could you easily tell like you were looking for the unencrypted disks here? Maybe, maybe not, based on like you see this little line here. Is it 1 or 0? Who knows, you know? So it's just like not having to know that bit. It's just knowing you should write it should be, or maybe it should be encrypted, you know? And you can write those syntactic sugars yourself too to add more syntactic sugar on top of InSpec, and you could share that with your team. So yeah, like why? Like all this, right? So it's just like automating tasks, and I've been kind of harking on that bit. A lot of these tasks and a lot of the stuff that I've been researching, since I don't science is my day job or anything like that, I've never had to thankfully have never had to go through like a terrible audit or anything like that. I don't have to do continuous audits in my day job or anything like that. I just don't like doing manual tasks. And so whenever I have a framework to help me not do manual tasks, I usually go and try to learn a little bit about it. And I find that would be very important, especially when you start just like one box, you can do the manual tasks. If you have like 2 boxes in their different operating systems, you can do the manual tasks. And all right, we have another operating system entirely at this point, and we have 3 boxes, and we could build this up. But when stuff gets larger and larger, these become just unwieldy, and these manual tasks just simply are not scalable, and they're really not helping the value of businesses in many cases. It really becomes very important to codify these tasks, so when you do have stuff go out of compliance, you can automatically check these things, and you could see those things very clearly. And whether it's in a thing that you built with Elasticsearch to be able to see the boxes that are out of compliance in whatever visualization you want, you can build out those tools, and you can still check. You can check the state of your system in a nice way. And when you are pumping this stuff into Elasticsearch and doing these automated checks, and you're doing them continuously, you have a really, really great detailed audit log of how your systems have been in compliant or not in compliant, or what are they being in compliant to over time. Whether you're keeping in Git, keeping in Elasticsearch, these become very, very powerful tools to, again, keep track of stuff over time. And the standardization becomes very important. Obviously, like you don't need to always, you don't need to use InSpec for everything, though being able to look at every state of any system you have and being able to have one tool in order to inspect those things to check whether or not they are not complying to whatever your policies are. This becomes very, very, very nice, especially because when you have shareable logic in between these different systems, you just literally copy paste code, or you git pull down a plugin or anything like that. And it obviously should augment your written policies. No, not everything could be totally written out in InSpec. Not all policies are like that clear and straightforward at the end of the day, but you could augment your written policies with something that lives in a continuous integration or just like a cron job schedule task sort of manner. And that's just genuinely great because I like actionable tasks, right? I like the ability to have a task that I can do and I can go do that thing without having a whole bunch of knowledge about the task. In the case of the written policy, I could run a CIS benchmark that I don't know any of the benchmarks, but I could like run it since a lot of them have been codified on GitHub and exist for free for you to use. Like you could actually like run InSpec exec and then the path to the GitHub website, and it'll then take that InSpec thing off the GitHub and it'll run it. This exists for Kubernetes, Docker, etc. And so very, very nice. And these automated guardrails for developers or engineers or whatever the case is. It becomes very hard to manage all the details in your infrastructure as code bit. There's so many different moving parts. So if you do know something is continuously stumping whoever is on your team that you're trying to help, you can really provide value by saying, well, you keep doing this thing, how about we add a check to see that you are actually following the proper guidelines for this case, whether it's like an SSH configuration, whatever it is. You can describe HTTP endpoints. They should be returning this kind of data for anything like that with InSpec. Because again, it's a general purpose testing framework. And it provides metrics, right? So you have the results of the test, you can then put them somewhere, and you can then track that over time. So very, very nice. And in general, I did go relatively fast, but that's okay. I was very excited. And I'll obviously have questions, but that's basically it. It's not a whole bunch at the end of the day. InSpec is a great framework in the case that you do not need to have a whole bunch to get started with. The community has really came out in force and is showing a lot of great work that I can't believe I didn't have a slide on this, but DevSec, github.com/devsec, they're doing some great InSpec work and building out stuff again for the Docker, Kubernetes. They're already taking those CIS benchmarks and are codifying them in their open source. And if you see a problem with them or anything like that, like that's not how you actually prove that or whatever, you can make an issue on GitHub. And it becomes a great community collaboration in those cases when, you know, we're all having the same problems. We could share a solution or fix the solutions when they're not correct. And so that's really it. I totally do questions. I talk about this afterwards or whatever the case is. And that's it. Yeah. Sure. So sometimes what do you mean specifically client level? Like a JavaScript? So that'd be like clients on a browser. I do JavaScript, yes. Yeah, JavaScript, Python, I do Go, whatever the languages. I'm not necessarily scared of languages. I know there's gonna be an API to do a thing. So if it's in C++, I genuinely am not scared of tackling in that case. Whether it's Ruby, Go, Python, a lot of the things, what I'll do is I'll pick, well, what is the best of open source available API that is out there? And if there's and if it's in a different language and I'm super comfortable in, I don't mind tackling in that case. And I've learned a whole bunch of different languages that way. Sure. Yeah. Yeah. So InSpec does not. No. Yeah. So InSpec. That's a great point. InSpec does not require Ruby to be on your system. That's a very clear point. Ruby does need to be on, like, for example, if I'm going to test your 350 clients out on, let's say they're on the Wi-Fi, whatever. I just need InSpec on my laptop here. It is agentless in the case that as long as they have SSH or WinRM, whatever the case is, and in general, most people already have those things set up. You just need to then log into it, check the state of the system, and it'll report back to you. No Ruby is needed to be installed since it is running literally commands under the hood. You know, like just like they're shelling out. So it just wraps it up in a tax, which becomes very nice. And you can obviously build out your tests so you can have it actually run fast. We could talk about this later. Yeah, great. Yeah, any other questions? That's a great question. Favorite Miyazaki movie? I really like Spirited Away at the end of the day. Yeah, really love Spirited Away. Any other? Thank you so much. All right.